So good morning, everybody. And on Tuesday, we have studied this page 10, and I have told you how to break down a long piece of English, and how to study the sentences one by one. Now, so this is talking about this page is talking about how to add three forces together. So, and it is we cannot use trigonometry. I'm not sure whether I talk about this stuff. So, this one is the Chinese is this one, and the Chinese is this one, and so if we have three forces or more forces, then of course we have a polygon. Then polygon that we cannot use this one, right? So what we usually do is if we add three or more forces together, we break it down into I and J, and then we add the x components and the y components separately. Separately is this one. Separately. We add the x component and the x components and the y components separately. So if we add them separately, that we have then we add the. Oh, wait a minute. I think I should use this. Just give me a minute. Oops. Okay, now, and so we use we add x and y components separately. Now, and of course you know how to do the mathematics, and in this book that it tells you that it can be done in 3 steps, and at last the book says the procedure will require almost efficiency. Computations are arranged in the table. Here that efficiency means this one, and this one is table is calculus. Now, so if we add three or more forces together, that we, of course, that you know that we do the x and then we do the y, and the book says it is the best way to do these in a table. Okay. So I will show you how to do this, and the TA will give you the homework later today or tomorrow, and please try to use the table to do the calculations. Okay. And if we are okay, then we go on to the next page. So this is sample problem 2.3. It should be on page 33 of the book. And we have 4 forces, and F1 is here, F2, F3, and F4. And 4 forces act on both A as shown, and determine what do we need to calculate. Determine the resultant of forces on the boat. Okay, determine the resultant. So this one is so we determine the resultant the sum of the 4 forces. Okay. Now And to write the solution, that for you to begin with, if I give you a question like this, that you work on from here. So what do we write here? Left, okay? That's the resultant to be R, okay? There should be only one person, so I should put one space here. That's the resultant be R, okay? And now, of course, you know R is equal to F1 plus F2 plus F3 plus F4, right? So we have, how many forces do we have here? 4. So we cannot use sine or cosine or triangle, okay? Now, so we break down into horizontal and vertical components. Horizontal and vertical components. So horizontal, of course, it means x, and vertical is y, okay? Now, and for here that, on page 10, the book says it is better to write it in a table. So we draw a table here. So the table looks like this, that we have, of course, in tables, I'm not sure about the Chinese, but in English, that we say this as columns. And we have different rows. Okay. And for the first column, we write down the names of the forces, and F1, F2, F3, and F4. And we write down the magnitudes. Of course, these are given in the question. You can look at the figure, and you know what. The first one is 150, the second one is 80, and so on. Now, in the third column, that it is we write down the angles. Sorry, that I forgot to mark F1. Right. Okay. This one should be 30 degrees. Please put it back here. Now, so I write then in the table we need to write down the angles of all forces. Okay. Remember one thing, that by writing this angle, theta, it goes from here. Theta equal to 0 is here. Theta equal to 0 degree is here. So which way is positive? Which way is positive? Counterclockwise or clockwise? Going up. Okay. So this one is actually I don't need to put the plus sign, but for positive theta, it is going counterclockwise. Okay. And counterclockwise, I have written it somewhere in front, and I've written it here. So on page 9, I've written it is this is page 9. Oh. Now theta is equal to 0 is here. That we go counterclockwise. Okay. So we go back to page 11. So this one. So I mark it here, and I mark it here, page 9. So theta is from going counterclockwise from the right hand side and go up. Now, so the next point is what are the angles of F1 to F4? So let's try. So for F1, it should be easy because it is 30 degrees from here. So F1 is 30 degrees. I'll fill in the table in a minute, okay? This is 30 degrees, okay? And for F2, what is the angle of F2? It is 20 degrees here, but the answer is not 20 degrees in this in the table, okay? So what's the angle here? So it should go from here and then go all the way counterclockwise, okay? So how much is it? So it should be 110, okay? And for the third one, for F3, so it goes from the from x-axis and then go up and then go down and then here. So it should be 270, very good. And then for the last one, for F4, the book gives 15 degrees here, so it is easy to think about. Oh, it should be 15 degrees. No, we should always go up from x-axis, go all the way to here. Okay, so this one is 345 degrees. It's okay. So let me fill in the table. So this one is 30. The second one is 110. That one is 270, and the last one is 345. It's okay. After we fill in these two, the column 2 and column 3, now we go to calculate the x and y components. Now, for x component, it is equal to f cosine theta. These are also on page 9. Okay, these are also on page 9. So x component is equal to f cosine theta, and y component equal to y f sine theta. So I'll do an example. So the for F1 that it should be, and f cosine theta should be 129.9 Newton, and f sine theta is 75 Newton. And is that okay? So this one is simply 150 times cosine 30 degrees, and if you have a calculator with you, you can try to calculate it. If you have a calculator with you, that you can see if the answer is correct. And then I will leave these for you to fill it at home by reading the book, or you simply use a calculator and do the rest. So we are doing because the resultant is the sum of all forces. So for x and y components, we are also adding them together to give the sum. We are adding this one, this one, this one, this one, and we add them together to get the sum here. And for y component, it's the same. Then we add this one, this one, this one, this one, and give the sum here. It's okay. Any problem with the calculations? No. So now the sum would be For X component, it will be 199.1 Newton. And for Y component, it is 14.3 Newtons. You can do it at home. So, and I assume if I give you, if you have X and Y component like, so this one, if for answering this question, that of course R is equal to 199.1 I plus 14.3 J Newton. I accept this answer, but some professors do not. So I'm okay with this, but some of the professors do not. So I reminded you that I told you to write it down in the formal way. This one is okay, but this one is the formal way of writing a force standard formal, and formal method, I would say. Now, to write it in the formal way, that of course that we calculate the magnitude of R, which is 199.69. You know how to do it, right? If I have the X component with the Y component, you know how to do the magnitude, right? So I don't write it down, okay? And for the angle, it is arctangent, 40.3 over 199.1, that's 4.1 degrees. So this one, the answer would be R equals to 199.6, and then it should be 4.1 degrees. I think I'll put it again. Okay, this is the answer. It's okay. So I think the mathematics part should be all right to you. Just I want the key point in this problem is do your calculations in a table. Okay. If there are more than three forces or more than three forces, then do them in a table. It is easier. Now, I'll give you a bit more time, and so if I see most of you are okay, then I will go on to the next page. Equilibrium of a particle. Equilibrium is this one, 平衡了。Equilibrium. So actually, we are doing the Newton's first law. In the whole course, in the whole statics course, we are doing Newton's first law. And in dynamics, maybe you don't know, but and the second law goes to dynamics. Okay, goes to the next semester. So definition. So what does it mean by equilibrium? Equilibrium is the resultant of all forces acting on a particle is zero. Okay. I think there are no new words here, so resultants 合力 acting on a 事例 or 画面都是可力。Okay. Now, so and the definition in the sentence is like this. So we have on top, but of course, besides using words, we have mathematical expression or graphical expression. So, of course, I assume you know how to write this in mathematics. So here then it is summation of f equal to 0. This one we say it as summation. We add everything together, it is summation, okay? This is the mathematical expression. Besides mathematical expression, we have graphical expression because we say if we add, for example, if we add f1 and f2, we can use triangle rule to say, oh, this one is f1 plus f2, right? And then if we add f1, f2, and f3, then of course we have f1 plus f2 plus f3, so we have this one. So we say that for on the diagram above that we have 4 forces, and if we add them together, it is equal to 0. It means that the f1 plus f2 plus f3 plus f4, this one is summation f equal to 0, right? So it does not have, it goes back to the same point. It goes back to the same point. So we say this one is a closed polygon. So it has many sides, but it goes back to the same point. So this one is a closed polygon. It does not have there's no space here. Okay, so we call it a closed polygon. This one can be useful. This one can be useful in some problems. Okay, this one can be used in some problems. Now, this one is for these things. That these are the Newton's first law. I think you have learned this in high school. And for the next thing is also learned in high school, but it is more important in statics. So this is a free body diagram. Free body diagram is this one. I think you may have seen it in your physics class. You may have seen it, and but this is very important in the statics class that it must be drawn before calculations involving equilibrium. Involving is 建设嘛. The thing is, no, you can interpret that. The thing is, as long as your answer has this one summation f equal to 0, then I need to see a free body diagram. Okay. Let's go back to the last page. For problem like this, for from like on page 11 that we are only calculating R equals to F1 plus F2 plus F3 plus F4. So there is no, we are not doing this. We don't have this equation. So it is okay not to draw diagram. But if, as long as your answer has, as long as you use this equation, that it must be drawn, okay? So the first thing is usually I would put, let's talk about examples. So if the question is asking about this one, that the three-point diagrams usually take about 25% to 30% of the mark, okay? So if I put 10 marks in a question, then this one will at least have 2.5 to 3 points here, okay? So it's okay. So you may think, oh, you think I know how to do the calculations, but you don't draw, you do not have a three-point diagram. So you can get 7 or 7.5 at most. Is that okay? Now, so this must be drawn before calculations involving equilibrium. Now, and there are two key points here. The first point, it shows all external forces acting on a body. Forces 所有 external forces means YD. Okay. It shows all external forces acting on the body. This is the first point. And and the second point is maybe I should go on with the figures on the right, and in the past I asked your seniors to draw this, but yeah, now you don't need to draw it again. For example, that you are standing on the ground, okay? You are standing on a floor. Now, of course, that you are standing on the floor. So how should we draw the three-point diagram of a person standing on the floor? Let's try this. Which forces should I draw here? Of course, there are forces, right? That you have learned in physics that if you stand on the you're standing on the floor, you're standing here, that it can be there is Newton's first law that we have, and we have Newton's third law. We have action and reaction, right? So how should we draw the three-point diagram? What forces should we add? The very first one is the weight of yourself, right? So mg. What else? So where should I add the reactions? Where should I add this one? This one. Okay, very good. So we have the 2 feet. So we have R1 and R2, right? This is the, you should have learned this in physics. And of course, we are doing much more difficult problems than this one. And let me give you a hint. Let me give you a hint. It is not in the book, so you may write it down. All other bodies in contact with a body have, oh, sorry, I'll see, just write it down. Acting on the body. The thing here is that the biggest problem of your seniors in drawing free body diagrams is that for example, here we should have three forces that sometimes your seniors would just draw two. That sometimes your seniors are missing the forces that should be drawn. For example, if there should be five, that your senior would just draw 3 or 4. If your diagram is wrong, that your calculations will be wrong. Okay. If your diagram has some forces missing, then your calculations will be wrong, and then your whole questions, the whole answer will be wrong. So to check if you have all forces, to check that to check that all forces should be here that all other forces in contact as long as it has contact with the body should have forces acting on the body. It can be equal to 0, but remember that if other bodies have contact, the J2, then it should have forces, okay? For example, that I am standing here, that of course there are reactions from the floor. If my hand is touching the desk here, the desk has force onto my hand, okay? And so all other bodies in contact with me have forces acting on me. Sometimes after some calculations that it is equal to 0, it is okay. But for example, if you forget to write down R1, that your whole calculation will be wrong. It's okay. Now let's go on to working on an example. We go on to the sample problem 2.6. And this one is a this one is a test channel. And we have flow here. So we have water flowing in this direction. Okay, we have water flowing in this direction. And of course, because this is a this is the hole, okay? And we put it in a test channel, and there is water flowing to the right. Okay. So what does it give? What does the problem give you? And the problem gives the question gives the tension is 200 Newton in AB here, and 300 Newton in AE here. And what do we need to determine? Okay, the question is long, but it is okay because which word are we going to find? If you don't know what is it asking, which word should we look for? Determine, okay? Determine and determine the drag force exerted on the hull, exerted on its axon, and then and the tension in cable AC. So we are determining two things. Okay. So now and here that we are, because it is in equilibrium. So and we have we need to draw a, because it is in equilibrium. So we need to draw a free-body diagram. And before drawing the free-body diagram, that I want to ask how many forces are here in this problem. We have cables here, so we have at least 3 forces. How many forces do we have in this problem? 3, at least 3, right? 3, 4, 5, 6, 7. How many? In this problem, remember that actually the question gives you some hints. It also asks you to determine the drag force. The drag force is this one. So there is a force on top of these 3 forces that we have this one. Okay. So in this problem we have 4 forces. Okay. Sometimes the problem comes from here that you see 1 cable, 2 cable, and 3 cables, and then you say, oh, we have three forces, and we add these 3, and then it equals to 0. Then you forget this one, and you don't know how to go on. Okay, or your answer will be wrong. Remember, we have 4 forces here. It's okay. So and then we go on to we let cables in AB, AC, and AB, TAB, TAC, and TAE, and then we let, because the question asks for the drag force, so we say let FD be the drag force. Okay. What should we do next? Okay, we have the symbols, and remember in this problem we are working with summation f equal to 0. So what do we need before calculations? Free-body diagram. Okay. Free-body diagram cannot be drawn here. It cannot be drawn here. Okay. It must be drawn separately. I will write FDD. Usually we would say use drawn separately. Okay. So we have, I will stop after drawing the three-quarter diagram. So we have x-axis and y-axis here. I'm sorry. X and y-axis here, and we have four forces. Okay. So the first one is TAB. TAB is 200 Newton. And we know the direction of TAB is alpha here. And then we have TAC here, right? Do we know how large is TAC? Do we know? Do we know? So we have TAC is just leave it as it is. Just leave it here, and then we know the angle is beta. And we have TAE. TAE is going downwards. So this one is TAE is 300 Newton. Okay, I put it on the right. And we have FD. So we don't know the magnitude of FD because we need to determine FD. Do we know the direction of FD? Because the water is flowing to the left, from the left to the right, the water is flowing from this way. So the shape is here. So the water flows here. So actually the drag force is going to the right. Okay. This one is empty. Okay, then how many forces do we have in this problem? 3 or 4 or 5? 4. How many forces do we have on this diagram? We have TAB, we have TAC, we have TAE, and we have FD, so we have 4. Okay, so this is complete. So we have finished drawing our three-quarter diagram. Okay, then I'll stop here for today.